Hi, welcome back to my channel. My name is Gina. A few weeks ago, we looked at the matrix multiplication, and we learned that we can write a linear system as an augmented matrix. In this video, we are going to look at 3 examples of solving a linear system from reducing an augmented matrix. Let's do a quick recap. We can solve a linear system using 2 types of elimination. For Gauss-Jordan elimination, we want to reduce the matrix to RREF. As for the Gaussian elimination, we want to reduce our augmented matrix into reduced echelon form. Let's look at the first example. Here we have 3 equations with 2 unknowns. If we write this system as an augmented matrix, we get 2, 3, equals to negative 1, 2, 1 equals to 5, and 1, 1 equals to 1. Now let's reduce the matrix. We want to have the pivot equals to 1, so I can interchange row 1 with row 3. Then my matrix becomes 1, 1, equals to 1. The second row remains the same, 2, 1, and 5. And the third row is now 2, 3, and negative 1. So I got my first pivot here. Now I would like to make the other entries in this column to be 0. So I want to eliminate this 2 and this 2. Then I can replace row 2 by row 2 minus 2 times row 1, and I'm going to replace row 3 by row 3 minus 2 times row 1. So by performing these 2 elementary row operations, my matrix becomes 1, 1, and 1. First row remains the same. Second row is now 0, and 1 minus 2 times 1, that is negative 1, and 5 minus 2 times 1, that is 3. And the third row is 0, and 3 minus 2 times 1, that is 1, and negative 1 minus 2 times 1, that is negative 3. So now we have our first pivot, and in this column, all the other entries are 0. Now let's move on to the second pivot. The second pivot will be in row 2, but we want our pivot to equals to 1. So what we can do is we can replace row 2 by negative of row 2. Then the matrix becomes 1, 1, and 1, 0, 1, and negative 3, 0, 1, and negative 3. So we have our first pivot and second pivot both equal to 1. But in the second column, we want to make the other entries other than the pivot to be 0. So we want to eliminate this 1 and this 1. Then we can do row 1 becomes row 1 minus row 2, and row 3 becomes row 3 minus row 2. Then the matrix becomes 1, 0, and 1 minus negative 3, that equals to 4. Second row remains the same, 0, 1, and negative 3. And third row is now 0, 0, and 0. So now we have 2 pivots, and in these 2 columns, the other entries other than the pivots are all 0. So what is the solution to this system? We wrote the system in matrix form. The first column represents the first variable, x, and the second column represents the second variable, y. So after we did a lot of elementary row operations, we get to this form. But again, the first column represents the x, second column represents the y. So from this reduced matrix, we get First row says 1 times x plus 0 times y equals to 4. Second row says 0 times x plus 1 times y equals to negative 3. And the third row says 0 times x plus 0 times y equals to 0. So 0 equals to 0. So the solution to this system of equation is x equals to 4 and y equals to negative 3. Now let's look at the second example. Here we have 3 unknowns with 3 equations. So again, we are going to write this in matrix form. Now we get our augmented matrix. We need to reduce this matrix into reduced form, and that'll be easier to find the solution. So the first step, let's find the first pivot. It should be in the first row. So we need to make the other entries in the first column to be 0. So we want to eliminate this one. Then we can do row 3 becomes row 3 minus row 2. Then the matrix becomes 1, 2, 4, and 6. Then 0, 1, 2, and 3. Last row will be 0 and 1 minus 2, negative 1. 2 minus 4, negative 2. And 1 minus 6, negative 5. So we have our first pivot ready. Now let's move on to the second pivot here. So we need to eliminate the 2 and the negative 1. I'm going to replace row 1 by row 1 minus 2 times row 2 and replace row 3 by row 3 plus row 2. Now we have an augmented matrix in reduced row-echelon form. We have the first pivot here, and the other 2 entries are 0. And the second pivot is here, and the other 2 entries in the second column are also 0. So what does this matrix tell us? From the first row, we get 1 times x plus 0 times y plus 0 times z equals to 0. The second row, we have 0 times x plus 1 times y plus 2 times z equals to 3. How about the third one? We have 0 times x plus 0 times y plus 0 times z. So the left-hand side is 0, but the right-hand side is negative 2. But 0 does not equals to negative 2. So the solution to this linear system is no solution. Now let's look at the last example. Here we have 5 unknowns and 4 equations. So if I write this as a matrix form, we want the pivot to be 1. So I'm going to interchange row 1 with row 2. So here's my first pivot. Now I want to eliminate this negative 1 and this 2. Then I can replace row 3 by row 3 plus row 1 and replace row 4 by row 4 minus 2 times row 1. Then the matrix becomes, so here's our first pivot. In the second column, we don't have a pivot, so the second pivot is this one. Now we want to eliminate this negative 2 and this 3. So we can replace row 1 by row 1 plus 2 times row 2, and row 4 can be replaced by row 4 minus 3 times row 2. So now we have our first and second pivots ready. Let's move on to the third pivot. So we want to make this negative 3 into 1. And I need to eliminate the 2, the 1, and the negative 3. So the first step, I can replace row 3 by negative 1/3 times row 3. Then this negative 3 will become 1. then I can do row 1 becomes row 1 minus 2 times row 3. Row 2 becomes row 2 minus row 3. And row 3 becomes row 3 plus 3 times row 3. So now the matrix is in reduced row echelon form, and we have 3 pivots. What does this matrix tell us? In the first row, it says x1 plus x2 plus x5 equals to 0. Second row says x3 plus x5 equals to 0. And the third row says x4 equals to 0. And the last row says 0 equals to 0, which is consistent. The 3 variables that are the pivot are x1, x3, and x4. So now I'm going to write the other 2 variables to the right hand side, and I'm going to name them as a free variable. I'm going to name x2 as s and x5 as t. Then I can rewrite the solution as x1 equals to negative s minus t, and x2 can be anything. x2 equals to the free variable s, and x3 from the second equation on the left, it equals to negative x5, which is negative t, and x4 equals to 0, and x5 can be anything. It equals to the free variable t. So that is the solution to this system. I can also write the solution in vector form. x1, x2, x3, x4, and x5 equals. I can factor out the s. So now I look for the coefficient in front of s. In x1, there's a negative 1, x2 is 1, x3 is 0, x4 is also 0, and x5 is also 0. So if I factor out the s, I get negative 1, 1, 0, 0, and 0. Then plus the second free variable, t. If I factor out the t, I get a negative 1 from x1, 0 from x2, negative 1 from x3, 0 from x4, and 1 from x5. So in the solution, we have plus t times negative 1, 0, negative 1, 0, and 1. And the s and t are called the free variables because they can be any real number. So there could be infinitely many solutions to this system. So a quick summary of the video. In this video, we look at 3 examples. We solve the linear systems by reducing the augmented matrix. In the first example, the system has a unique solution because at the end we got x equals to a number and y equals to a number. In the second example, we found that the system has no solution because when we reduce the matrix, in the last row we have 0 equals to a non-zero number. So it is not consistent, so the system has no solution. In the last example, we look at an example of system that has infinitely many solutions. There are 2 variables that could be any number. So there are many possible solutions to the linear systems. So that concludes the video. In the next video, we are going to discuss how can we find whether a system has unique solution, no solution, or infinitely many solutions.